Hello children, welcome back to physics class. In today's class, let us discuss in detail regarding a very important concept in physics, that is magnetism. Let us begin. Children, in the early days like 600 BC, Greek people, these people have used a particular substance called a magnetite. In our general terms, it is called as lodestone. It is nothing but an iron ore, another form of a iron ore. Okay, so now our today's topic is all about your magnetism. Greek people in the early 600 BC, they used a specific substance, and that substance is a composition of iron ore, and its chemical formula is Fe3O4. This is also called as lodestone or magnetite. Do you know the reason why it is also called as magnetite? Because earlier I said that it was found in the place named Greek. So in that Greek country, there was a place named Magnesia. So as that substance was found in Magnesia, hence the name was given as magnetite. And what else? So apart from magnetite, it was also called as lodestone. So why the name lodestone was given means, in the early English, lodestone means the stone which shows the way or the path. Hence the name was given as lodestone. So now let us discuss in detail regarding how this stone leads to the way or path. This substance was actually used in navigation purpose. So earlier days, while doing the trade and all, these people used to go by a ship. So what they used to do is that they took this magnetite, this is Fe3O4, a small piece of this stone, this magnetic substance, which was attached to a wooden piece. So for the wooden piece, a small lodestone was being attached, and this was placed in a bowl containing of water. So what it used to do? It used to float on the water containing bowl. Later on, when it was released freely, it moves to and fro for a small time, and later on it comes to rest position. Whenever it comes to rest position, it always shows a particular direction. It always gets aligned in north-south direction. Again, when it is disturbed and released, it aligns in the north-south direction only. Hence, this helps us to lead the path. So people could make it out. So which direction to which country are these leading to? The ship is leading to. Okay. Hence, this substance is used to know the direction of the given place. Okay. So now, the piece of iron acquires whenever we take an iron, and if you start rubbing the iron piece with the lodestone, the piece of iron also get this magnetic property. That means it also gets the tendency to attract every other magnetic material. So what are magnetic material? Substances like lodestone, cobalt, nickel, iron, these are called as a magnetic substances. So whenever a piece of iron, cobalt or nickel is continuously rubbed with this substance called magnetite or lodestone, that also attains the property of attracting every other material. So one thing you need to know is, these magnetite or lodestone, whatever is there, this is found in nature. Hence, this is called as your natural magnetite, natural magnets. Whereas, after continuous rubbing or due to some other applications, a magnetic material like iron, cobalt, nickel can also be get magnetized. And this process of making magnetic materials like iron, cobalt, nickel as a magnetic substance, the process itself is called as your artificial methods, and hence these magnets are called as artificial magnets. Hence we can classify magnets into two types. One is natural magnets which are found in nature, and the other is artificial magnets which are made artificially. So now let us discuss the types of magnets in detail. First one is all about a bar magnet. So look at this, children, carefully. So first one, bar magnet. So let us see how a bar magnet looks like. These bar magnets are generally in a rectangular shape, rectangular bar shape, something like this. These two both are bar magnets. So here it has a rectangular shape, whereas this is having a cylindrical shape. So cylindrical bar magnet, rectangular bar magnet. So both are called as your bar magnets. So these bar magnets in general will be having two ends. One end is named as north pole, whereas the other end is named as your south pole. So these type of magnets are called as your bar magnet, circular cross section and rectangular cross section bar magnet. Each and every bar magnet has two poles. One is called as your north pole, the other is called as your south pole. Next set of magnets is all about your horseshoe magnets. So let us discuss in detail how a horseshoe magnet looks like. Did you ever observe the shape of a leg or a shoe of a horse? So at the bottom of the leg, the shape of the bottom of the leg, feet of the horse is something like this. Okay. So that magnet shape will also be in the same structure. If you attach a shoe to a horse, the shape of the horseshoe would be something like this. Hence, the shape of this is nothing but your U-shaped, isn't it, children? This is in the form of U, okay, U-shaped. The bar magnet is also looks something in that pattern. As I already told you that bar magnet has two poles. One is given as north pole, the other is south pole. So for this bar magnet, one is having a north pole, whereas the other one is having a south pole, and the structure itself is called as a horseshoe magnet. So these are the cylindrical cross section bar magnet, rectangular cross section bar magnet, whereas the U-shaped is called as your horseshoe bar magnet, which is also having two poles. One is your north pole, the other is your south pole. Children, always remember that for the North Pole and South Pole, generally North Pole from here to here it begins, we will discuss it in detail later, that is generally marked in red color painting. Let us now discuss in detail regarding the magnetic needle. Okay. So, coming to the magnetic needle. So, what exactly is a magnetic needle, my children? So, magnetic needle is generally a bar magnet which have two ends, and if you consider its shape, it is something like this. At the middle, it has a wide length, whereas at the corners, they are tapered something like this. Corners tapered and at the middle little wider condition. So a magnet is again in the form of a bar but tapered at its end and is further pivoted at on the small stand. A stand is taken. On the stand, this needle is being kept. This bar magnet, which is very narrow, which is tapered at its center, little wider, and at the corners it is been narrow. Okay, and this is being gently placed on the pointer, gently placed on a needle. Okay, so when it is left as it is, when it is left freely, what happens? This will oscillate for a while and two poles, one is north pole, the other is south pole. After coming to, it will rotate for a while and then comes to a rest position. Whenever it comes to a rest position, one part will be showing the north direction and the other part will be showing the south direction. So, this itself is called as a magnetic needle. So, let us try to understand something regarding the magnetic compass. You know compass, generally people used to play with the small compass in keychains and all, it is been attached. How does it look like, children? So, magnetic compass. I hope you generally use compass needles, keychains. So, it is in real life it is generally made up of a brass material. So, a brass material is taken in which glass upper edge is made with a glass, okay, so that you can see into that. So, something like this made of copper. A copper bottom is taken on which something like it is covered with a glass plate. Okay, upper is glass plate, bottom is made up of brass material, made of brass, and inside which this, I told you this is a compass needle pivoted at its center. So, again a small needle like structure, this small needle is being kept on this, which again is having a north-south direction. This itself is called as a compass needle. Okay children. So earlier I told you all about a bar magnet. Bar magnet is again two types. One is the cylindrical cross section bar magnet, rectangular cross section bar magnet. Second is all about your horseshoe magnet. So how does a horseshoe magnet looks like? Horseshoe magnet looks like the shape of a horse, shoe of a horse. Okay. So that means U-shaped. Later on I was discussing regarding the magnetic needle. How does a magnetic needle looks like? Some like bar like structure is taken which is wider at the middle and tapered at the edges. And this is also having two poles, one is north pole, the other is south pole, and this is gently placed on the pointed stand which indicates the north-south direction. This is called as a compass needle. Next one is all about your magnetic compass. How does a magnetic compass looks like? It is a bowl shaped, a small bowl shape will be there, made up of a copper one, a small piece will be there, and upper is made up of some glass plate, and inside we will be placing a small magnetic needle inside that which is pivoted on a needle. And when it is released, it oscillates for a while and again comes to a rest position showing towards the north-south direction. And one more thing you need to understand about a electromagnet. So the last one is all about your electromagnet. So what is an electromagnet, children? You need to consider a bar magnet, iron. First of all, take a piece of iron. An iron piece is taken. This iron piece, copper wire, something like copper wire is wound around it. And then current is passed through this. Our battery of some voltage is being, potential difference is being applied, and whenever a copper wire is wound around the magnetic iron ore. So you have to consider an iron ore around which copper wires to be wounded out, and two ends of the copper wire to be attached with the battery. So this is indicates V. V means volts. Volt is a unit for potential difference. Some battery is being connected. Whenever battery is being connected, battery have two terminals, positive terminal and negative terminal. So whenever the switch is on, current starts flowing from the battery. Let us suppose that current has some I. This current has some I. So whenever a current is flowing, this is initially it was only an iron rod. But what we are doing, current is been passing round the iron coil, iron bar. So whatever, as long as the iron current passes through this wounded wire actually called as solenoid. Okay. So whenever the current, as long as the switch is on and the current passes through the circuit, then this iron attains a property of attracting magnetic material. As long as the current is passing on, this iron starts attracting the magnetic materials. And whenever we stop the current to flow, it will not attract any magnetic materials. So this is the last case of electromagnets. I hope you understood the types of magnets and the history regarding the magnets. Okay. So now we will take a break until now and we will meet in the next video. Until then, take care children. Good day.